Hello, my dear students and listeners at home. You are welcome to today's online teaching from St. Charles College, Onitsha. I am Uche Muokwue, your chemistry teacher. In our today's discussion, we are going to look at hydrocarbon. Before we proceed, let us look at the specific objective of today's lesson. My dear students, by the end of the lesson, you will be able to, number 1, define hydrocarbon. Number 2, give reasons why carbon forms numerous compounds. Number 3, state the classes of hydrocarbon and give example of each. Number 4, define homologous series. Number 5, state at least 4 characteristics of a homologous series. Finally, explain the meaning of functional group using example. Let us now look at what we have for today. My dear students, your SS1, we learned metals and non-metals. We learned that metals are at the left-hand side of the periodic table, while non-metals are at the right-hand side. Hydrogen is a metal, while carbon is a non-metal. Carbon will combine covalently with hydrogen to form hydrocarbon. Therefore, hydrocarbons are organic compounds containing carbon and hydrogen only. They have the general molecular formula of CSHY, where S and Y are positive whole numbers. Example of hydrocarbon includes methane, CH4, propane, C3H8, ethene, C2H4, benzene, C6H6, and so on. Hydrocarbons occur naturally in natural gases, coal, and petroleum. There are a lot of compounds that contains a carbon atom. Let us now see the reason why carbon forms numerous organic compounds. If we look around us today, we'll discover that there are over 2 million compounds that contains carbon. In our various homes, there are many household materials like soap, detergent, plastic containers like cup, buckets, carpets, mattresses, pillows, clothing materials like polyester, nylon, dye, buttons, even drugs like paracetamol, aspirin, cough relieving tablets. There are also carbon atoms that occurs. There are also carbon compounds that occurs naturally in plants like carbohydrates, vegetable oil, in animals as fats, protein, oils, and so on. Let us now see the reason why carbon occurs like that. As I said earlier on, that carbon is a non-metal and it belongs to group 4 of the periodic table. Carbon has 6 electrons with 4 valency electrons. Carbon cannot lose 4 valency electrons to become C4 plus compound, neither can it gain 4 electrons to become C minus 4 compounds. The only option that is left for carbon is to form a covalent compound with other elements because it cannot form ionic compounds. Because of that, carbon, because of its numerous outermost shell electron, carbon reacts to form, number 1, variety or multiple bonds. Carbon can form 4 single bonds, as in alkane, 1 double bond with 2 single bonds, as in alkene, 1 triple bond with 1 single bond, as in alkene. In all these compounds, the gold octet state is attained. Another reason why carbon forms numerous organic compounds is because of its ability to undergo catenation. Catenation is the ability of carbon to combine with one another to form straight chain, branch chain, and ring chain compounds containing many carbon atoms. For example, on the screen, you see the first compound here, hexane. Hexane is a straight chain compound. A straight chain carbon compound containing 6 carbon atoms and 14 hydrogen atoms. This straight chain compound can be rearranged to be in form of a branch chain, as in 2,3-dimethyl butane. Can also be rearranged to be in a circular form, as in cyclohexane. The third reason why carbon forms numerous compounds is because of its easy reaction with nonmetals. The presence of 4 unpaired valency electrons enables carbon to react easily with nonmetals like hydrogen, oxygen, nitrogen, halogens. And the high strength of the bond carbon formed with these nonmetals makes the reversibility of the reaction difficult, such that these nonmetals, once they are formed, are not easily released to form other compounds other than compounds of carbon. So you now see that because carbon can undergo catenation, it can be arranged in different forms, either in a straight chain, in a branch chain, or in a circular form. It also forms varieties of bonds, triple bonds, single bonds, double bonds, and reacts with almost all non-metals. Because of that, we have so many organic compounds that contains carbon atom. Classifications of hydrocarbon. Because there are numerous organic compounds of carbon, hydrocarbons are classified into 3 main groups based on their skeletal arrangement of atoms in their molecule. The first one is aliphatic hydrocarbon. Aliphatic hydrocarbons are compounds whose molecules are composed of common atoms in a straight chain, like an alkane. Example is ethane. Alkene, like in propane. Alkene, like in alkene. Or in branch chain, as in 3-methyl pentane, and so on. The second classes of hydrocarbon is alicyclic hydrocarbon. They are aliphatic hydrocarbon whose compounds contains carbon atom bonded together in a cyclic fashion. This group of hydrocarbons are aliphatic in nature, but they are arranged in such a way that they are in cyclic form. Example is cyclopropane. You see that it is in a triangular form. The other one is cyclobutene. It is in a square form. The third class is aromatic hydrocarbon. They are cyclic compounds based on benzene ring. They are described as benzene-like compounds. This group of hydrocarbon, they have benzene as their parent hydrocarbon. You can see the structure of benzene, and you can see the examples of aromatic hydrocarbon. The phenol having benzene as the parent hydrocarbon with OH as a substituent. The toluene, otherwise known as methylbenzene, it also has benzene as the parent hydrocarbon with methyl group as a substituent. Other examples include aniline, nitrobenzene, and so on. Homologous series. Because there are numerous organic compounds that contains carbon. Organic compounds are classified into or grouped into families. just as we come from different families. Therefore, homologous series is a family of organic compounds which follows a regular structural pattern in which each successive member differs in its molecular formula by a CH2 group or by 14 atomic mass unit. For example, the alkane. The alkane is the N family. The first member of the alkane is methane. The formula is CH4. The second member is ethane. Ethane is C2H6. Now the difference between CH4 and C2H6 is CH2. So each member differs from the successive one by a molecular formula of a CH2 group. And each individual member is referred to as a homologue. Each member of the family is referred to as a homologue. Characteristics of a homologous series. All members of the series share a general molecular formula. For example, the alkane is C2CN H2N plus 2. Alkene is CN H2N. Alkyne is CN H2N minus 2. Number 2 is that each successive member in the series differ in a molecular formula by addition of a CH2 group, meaning that each member, the difference between the first member and the second member of a series is CH2, and even the difference between the second member and the third member is also CH2, and so on. Number 3, each successive member differ in relative molecular mass by 14 atomic mass units. The CH2, C is for carbon. Carbon have atomic mass of 12. Hydrogen, H2, is 2. If you add 12 to 2, you get 14. Number 4, the chemical properties of the members are similar, meaning that the members behave alike. Number 5, the physical properties of the members changes gradually as the number of carbon atoms increases. For example, the alkanes from C1 to C4 are gases at room temperature. From C5 to C10 are liquid at room temperature. And from C11 and above are all solid at room temperature. Finally, all members can be prepared using the same method, meaning that if you know how to prepare the first member, you can use that same method. You can use that same method to prepare the second member, third members, and so on. Functional group. Functional group is an atom, radical, or bond common to a homologous series. It determines the main chemical properties of the series. Every functional group has its own characteristic properties. When two or more functional groups occurs in one molecule, the properties of one influences the presence of the other. Examples of functional group include, we have the alkane. The alkane, the functional group there is the single bond. An example is ethane. Ethane is CH3 double single bond CH3. Then the alkene. The alkene, they have the functional group there is the double bond. An example is ethene. The alkene, the functional group there is triple bond. An example of alkene is ethene. Alkanol. Alkanol has a functional group of OH. Example is methanol. The alkanoic acid, the functional group there is COOH. Example is ethanoic acid. The alkanals has the functional group of CHO. Example is ethanol. The alkanones, they have the functional group of C double bond O. Example is propanol. The alkanoids has the functional group of COO. An example is methyl ethanoate. The amines have a functional group of NH2. Example is ethenamide. The oxyalkane has a functional group of O. And the example is methoxymethane. So this functional group are the bonds that is common to every homologous series. My dear students, we've come to the end of today's lesson, and I would like to evaluate you using these questions. Number 1, define hydrocarbon. Number 2, give reasons why carbon form numerous organic compounds. Thirdly, state the classes of hydrocarbon and give example of each. Number 4, define homologous series. Number 5, state at least 5 characteristics of a homologous series. Finally, explain the meaning of functional group and give 3 examples. You can submit your questions and assignment to my WhatsApp number 08036271397 08036271397. And for our next lesson, I would like you to read up Aliphatic nomenclature for organic compounds and their isomerism. Thank you for listening.